So what we're doing is we're looking for sides. So we're going to set up our equations so that we look for, since we're looking for sides, we're either looking for the opposite, the adjacent, or the hypotenuse. And for instance, if the triangle you have, you're looking for the adjacent and you know the hypotenuse, you're going to look at the adjacent and the hypotenuse. So you know you're going to be using adjacent over hypotenuse, which is cosine theta. Let's look at an example. So the angle here we're looking at is 42 degrees, and I want to know x, and I know 3 for the sides. First thing we do is label our triangle. So across from the 90-degree angle is the hypotenuse, and the other angle that we know is 42 degrees. In between the right angle and the reference angle we're looking at is adjacent. Across from the 42-degree angle is the opposite. So then we look, and we're going to look at its SOHCAHTOA. It's just a way to remember. And the ones we're looking at that we need to use are the opposite and the hypotenuse. I don't care about A. I don't want to know it. I don't have any information on it, so I just forget about A. So I need O and H. That's going to be sine. And that equals sine theta. Okay, so that's the one we're starting with. Now we're going to replace the we're going to substitute all the information. So the opposite is x, hypotenuse is 3, and the angle is 42 degrees. Then we go use our calculator, and we find that the sine of 42 degrees is 0.669 approximately. To solve now, before we do that, now you have an equation that you can solve. We solve for x, which is the one we wanted to know. Multiply by 3 on both sides, and x equals 2.007. Well, it should be approximately, but that's it right there. Okay, next one. Let's do this triangle here. So this is the information we have. Again, we're going to label our triangle. So between the reference angle and the 90 degrees is the adjacent. Across from the 90-degree angle is the hypotenuse. Across from the reference angle is the opposite. And the ones we're going to look at, SOHCAHTOA. And the ones we need to know is the x, which is the opposite, and the one I have information on is the adjacent. I'm not going to worry about the hypotenuse because I don't need to know it. It's not asking me for that one. And the one I do have is the adjacent. So we'll start with that. And that's going to be the tangent. So SOHCAHTOA says it's a tangent. So that's opposite over adjacent, and that's going to be the tangent, sorry. So we substitute. Opposite is x, adjacent is 3. The tangent, the theta, the angle we're using is 53 degrees. The tangent of 53 degrees is 1.327 multiplied by 3. Oops. What happened there? Sorry, right there. Multiply by 3, And there you go. Okay. X is equal to approximately 3.981. I changed those to say approximately because we don't have an actual number for these. Another triangle. Label the triangle. We have our hypotenuse across from the 90-degree angle. We have our reference angle, which is 64 degrees. Between that and the right angle is the adjacent side, and opposite that angle is the opposite side. SOHCAHTOA says, we consult the Great SOHCAHTOA. As we consult the Great SOHCAHTOA, we want to know the hypotenuse, and the one we know is adjacent, so we're going to use cosine. Okay, and let's replace all our information, substitute. We know the adjacent is 10. We don't know the hypotenuse, so we called it x. And that's going to be the cosine of 64 degrees. The cosine of 64 degrees, 0.438. And as usual, we're going to multiply by our denominator to get that x out of there. And we're going to have move up to the top over here because there's not going to be room. Oops. 10 equals 0.438 when we multiply by x on both sides. Now we're going to divide by 0.438 on both sides. And we get 22.811, which sounds pretty good. And that's it. Those are your two examples.